Alright, today we're going to be talking about subtracting integers. And we used the counters yesterday to come up with some rules with subtracting integers. And today we're going to actually go ahead and make a rule for subtracting integers, but then use the counters to verify that it actually works. So subtracting integers, you are just going to add its opposite. So maybe you want to get a highlighter out and highlight that to subtract integer, we just add its opposite. A lot of you actually started to notice that that pattern was occurring when you were using your counters yesterday. So let's look at an example. We have 3 minus 5. Okay, to show this with the counters, my red is going to represent my negatives and my black is going to represent my positives. So if I go ahead and show 3, I need 3 black, because those are positive. Oh, sorry. So there's 1, here's 2, and here's 3. And I want to subtract 5, but I currently only have 3 counters. So in order to subtract 5, I actually need 5 black counters. And the only way I can do that is if I add a 0 pair. So here's a red and a black. I haven't added anything to my problem. It's still worth 3, my pile is. I'm going to go ahead and add 1 more black and 1 more red. And now my pile is still worth 3, but I also now have 5 black counters. So I can go ahead and take 5 away. 1, 2, 3, 4, and 5. And I'm left with 2 red. So I know that 3 minus 5 equals negative 2. Showing it as an addition problem, I'm going to go ahead and start with my original 3 black counters. 1, 2, 3. But now, instead of subtracting 5, I'm going to go ahead and add its opposite. So instead of subtracting 5, I'm going to add a negative. A lot of times you'll hear me say keep, change, change. You keep the first number the same, you change subtraction to addition, and then you change the value of the second integer to its opposite. So because it was 5, it's now negative 5. Keep, change, change. And now it says I'm going to go ahead and add negative 5. So I'm going to bring out 5 reds. 1, 2, 3, 4, and 5. And so now I look at my pile to find the value. I know that a red and a black equals 0, so I can get rid of a 0. I have another red and a black. That black does not want to leave. And then I have 1 more red and black that I can go ahead and get rid of a 0 pair. So I'm left with negative 2, which was the same as 3 minus 5. Okay? The nice thing about this is now you have addition problems, and you know the rules for addition. If the signs are the same, you add them together and you keep the same sign. And if the signs are different in the 2 add-ins, then you take the difference, and whichever value is heavier is the sign that the answer will take. So by making them into addition problems, it can help us to solve some of these other problems. So we have negative 4 minus negative 10. So if I wanted to do this and make it into an addition problem, I keep negative 4 the same, I change subtraction to addition, and I change the negative 10 to positive 10, which gets me negative 4 plus 10. So now I go ahead and use my rules. Are my signs the same? No. So I have to take the difference. 10 minus 4 equals 6. Which number is heavier? Farther from 0. 10 is, which means my answer is positive. And using this method to help subtracting can help alleviate a lot of problems. Now I do understand that there are times where subtraction might just be easier to do it as is. For example, if we had 10 minus 6, there's no reason to keep change, change because we know that 10 is larger than 6, and if we take 6 from 10, we have 4. So there are some cases where you may not choose to keep, change, change, but a lot of times, unless the positive, they're both positive, and unless the first number is larger, keep, change, change is a pretty solid method to use when you are solving these. I do want you to look at the note. When you have multiple subtraction signs, it is typically helpful to change everything to addition before you start. But you have to remember that every two numbers or integers with their subtraction sign in between is a separate subtraction problem. And so I'll go ahead and do an example like that on the next page just for you to see. All right, so we're going to go ahead and try a couple problems here. If we started with 3 minus 9, okay, I'm going to go ahead and do the keep, change, change. And when I do keep, change, change, I'm going to go ahead and keep the first number the same. So 3 is going to say 3. I'm going to change the subtraction to addition, and I take the opposite of the second value. So 9 is going to become negative 9. And so now I have 3 plus negative 9. The signs are different, so I take the difference. 9 minus 3 is 6. The value that's heavier is the negative 9, so my answer is negative 6. And I can demonstrate this with the tokens as well, because you can always go back to the tokens. Okay, if I do 3 minus 9, I have 3 black. I have to take away 9 black. Well, I only have 3, so in order to do this, I actually have to add some 0 pairs, 6 0 pairs. There's 2 0 pairs, 3 0 pairs, 4 0 pairs, 5 0 pairs, and 6 0 pairs. So now I have a total of 9 black, but the value of this pile is only 3 still because I have 6 red as well, which are the negative. And now I can go ahead and take all 9 away. 4, 5, 6, 7, 8, and 9. And so the value of my pile, when I bring these back together, are 6 reds, which represent the negative 6. Okay, so you can always go back to the tokens. You can keep, change, change to change it to addition. And then you can, or you can actually keep, change, change, and then use the tokens if you need those as well. So let's try another one. Let's go ahead and do negative 5 minus negative 5. Oftentimes, people will look at this and they get very nervous about this because you are subtracting a negative. And that's sometimes difficult for people to understand. So I can choose to keep, change, change. And I have negative 5. I'm going to keep it as negative 5. I change subtraction to addition. And then I change negative 5 to positive 5. So now I just have an addition problem. Okay, the signs are different, so I take the difference. Well, the difference of 5 and 5 is 0. And 0 is not positive or negative, so there is no value for that. So this answer is actually just 0. And I can always show it with, or demonstrate it with the tokens as well, or the counters. So I have 5 negative, and I'm taking away 5 negative. Well, when I take away 5 negative, I have 5 negative to take. 1, 2, 3, 4, 5. If they don't bounce, I'm left with nothing. So I have 0. Okay. What about this next one? We're going to go ahead and do a 4 minus negative 2 minus 5. And this is where you have multiple problems or multiple signs happening at the same time. And this is where I also talked about it being somewhat beneficial to actually change all the signs before you actually solve them. So if I look at this, 4 minus negative 2, I can go ahead and change that first subtraction problem. So it's going to stay as 4 plus, subtraction changes to positive, or addition. Negative 2 is going to change to the opposite, which is 2, and I still have minus 5. Now I still have a subtraction sign, so before I actually continue, I want to get everything addition first, and this is where it can really help you sometimes. So the first number in the second subtraction problem is the 2, so I keep it the same. Change. So I still have 4 plus 2 stays the same, subtraction changes to addition, and 5 is going to change to the opposite, which is negative 5. And now I have just addition problems. And this is where we talked about yesterday. We discussed in the beginning of class, the review, how oftentimes it's helpful to combine the integers that are the same sign first, and then combine it to different signs at the end. So if I look, because everything's addition, I can use the commutative property of addition. I have 4 plus 2, which equals 6, plus negative 5. The signs are different, so I take the difference, which is 1, because 6 is heavier than negative 5. My answer is going to be positive, so it's positive 1 or 1. And that will be the addition problem to this problem. All right, let's try one more. Let's go ahead and take negative 10 minus negative 6 minus 7. Okay? Again, I look at this. I'm going to go ahead and keep change. So I keep negative 10 as negative 10. I change subtraction to addition. I change negative 6 to positive 6. And then I have minus 7. I still have a subtraction problem, so I'm going to go ahead and keep change the second subtraction problem just to make everything addition. And I have negative 10 plus 6 stays the same. Subtraction changes to addition, and 7 will change to negative 7. And now I have negative 10 plus 6 plus negative 7. So to help me, I'm actually going to use the commutative property of addition and change the order of negative 7 and 6. So I get negative 10 plus negative 7 plus 6. I'm going to combine negative 10 and negative 7 to get negative 17. The signs are the same, so I add them together. And because they're both negative, it stays negative, plus the 6. The signs are different, so I take the difference. 17 minus 6 is 11. And the heavier value is the negative 17. It's farther from 0 than 6, so my answer is going to be negative 11. Okay? When you subtract, oftentimes it's easier to keep change, with the exception of the problems where the first value is larger, like 15 minus 5. We know 15 minus 5 is 10, and that one with the counters, a lot of people struggled with showing it with the counters because they thought that was fairly simplistic. That's something you've worked with before. That will not always be the case. The first value is not always larger than the second. So we need to understand that subtraction. Subtracting is taking away. However, when you don't have that number to take away, when you're subtracting a different sign, you actually have to add 0 pairs in order to get that sign to take those away. So that's why we're adding the opposite.